Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone. My name is Siti Sarah binti Mohamad Nor and I'm from group AP2205A, student of Bachelor of Surveying Science and Geomatics, UiTM Shalom. And this video is a presentation video of Global Navigation Satellite System GNSS data processing. This video is prepared for my lecturer, Surveyor Dr. Amir Sharifuddin Latip for GLS611 Advanced Geodesy, which in this video I will discuss and explain on what have I done for Global Navigation Satellite System data processing. So without further ado, let us start with what is Global Navigation Satellite System GNSS data processing. So, Global Navigation Satellite System, or GNSS, is basically a global system of satellites that transmit signals for navigation purposes on Earth. And as of the year of 2020, there are 4 main GNSS satellites, and the 4 main GNSS satellites are, first, GPS, which is America's Global Positioning System, and the second one is GLONASS, which is Russia's Orbiting Navigation Satellite System, and the third one is Beidou 2, which is a system developed by China, and the last one is Galileo, a system developed by European Union. Alright, so GNSS data processing can be divided into 2 stages. The first stage is pre-processing stage, where we need to perform the quality checking of our observation and navigation data before we can proceed with the processing stage. And the second stage is the processing stage, which involves 3 types of processing, which is baseline processing, independent baseline processing, and network adjustment. There are 4 softwares that we need to use to perform GNSS data processing, and the software that we need to use is, first, Articlip, second is Leica Spider QC software, the third one is Trimble Business Center, and the last one is Testpad or Notepad. So basically, the first, second, and fourth software, which is Articlip, Leica Spider QC software, and Testpad or Notepad, will be used for pre-processing stage, and the Trimble Business Center is the most important software because we need to use this software to do the processing stage. Okay, so let us start with the pre-processing stage, which is the evaluation of GNSS data quality. So to evaluate the GNSS data quality, there are several parameters that we need to take into account, and some of the parameters are, first, the overall data completeness. So what is data completeness? Data completeness is actually the percentage of the ratio between the observed data and expected data. For example, we expected our observation to be in 24 hours, but actually it turns out in the data it runs only for 2 hours. So we need to check on that regarding the data completeness. Okay, so the second parameter is the MP1 and MP2, which MP1 is actually the multipath error for L1 frequency, and MP2 is the multipath error for L2 frequency. So multipath can be defined as the propagation phenomenon that results in radio signals reaching and receiving antenna by 2 or more paths. Okay, so the next parameter is the total cycle slip. So what is cycle slip? Cycle slip is actually a discontinuity in a receiver's phase log on a satellite signal. So basically, it is a blockage of satellite signal that's supposed to reach the receiver. And a power loss, a very low signal to noise ratio, a failure of the receiver software, a malfunctioning satellite oscillator can cause a cycle slip. So the fourth parameter is the average track satellite, and the fifth is the dilution of precision, which known as DOP values, and this is actually the term used in the satellite navigation and geomatics engineering to specify the error propagation as a mathematical effect of navigation satellite geometry on positional measurement precision. And this is one of the most important parameters that we need to evaluate. Okay, so the second last parameter is the percentage of epochs, and the last one is the threshold value for the parameters above. So the threshold value, we can actually refer to the Department of Survey and Mapping Malaysia, which is the SMM, and also the regulation or circulars that from the other countries also. Okay. Now I will demonstrate on how did I perform the evaluation of GNSS data quality using the Leica Spider QC software. So first we need to open the Leica Spider QC software, and then the software will appear like this. And then we need to click on the QC button. QC stands for quality checking. Okay, so here we need to open our GNSS data, and we need to evaluate all the data. For example, we need to evaluate all the data in the data course L9. Also for the loop 9 data. But for this demonstration, I will only show you for the IR 041A00 20 observation data. So I will open this data. Okay, so it will appear like this. We can see here that it stated that the observation file is IR 041A00.20O. Okay, so actually, the O at the end of the name file refers to the observation file, and the N at the end of the file name refers to the navigation file. We need to bear in mind that the GNSS data, they need to have each other. They need to have the observation data as well as the navigation data, or else we can't perform the baseline processing. Okay, so here it shows that the quality testing is failed, and we need to also bear in mind that the threshold value for Leica Spider QC software is from the Leica Spider QC software. It's not from the Department of Survey and Mapping Malaysia or from the other countries. So we also need to do our own research on the threshold values from the Department of Survey and Mapping Malaysia, and also from other regulations and circulars from other countries. Okay, so here we can see the quality testing. We can also see that here the cycle slips fail because the value of the cycle slip is 237 slips, but the threshold value is only 95 slips. So here it means that the value of the cycle slip should be below than 95 slips, but here the value is 237 slips, so therefore the cycle slip for the quality testing has failed. Okay, so we can also see the DOP values here. The PDOP is minimum for the PDOP is 2.7, and the value for the minimum GDOP is 3.2. Okay. Next, we also can see all the informations of the data, and we need to evaluate for other data also, not only IR, and then we need to compare all the parameters that I have mentioned before in a table to actually see which data is actually good and acceptable based on each and every one of the threshold values for the parameters. Okay, so that's all for quality checking. using Leica Spider QC software. Alright, next, to strengthen our understanding and see the visualization of the data, we can also see the visualization of the data by launching the RTK launch. Okay. So this is actually RTK 2.4.2 software. Okay, you can see here. And then we need to open the RTK plot. Okay, so I'm not sure why my RTK plot can't open right now. But okay, so I will just show you the procedure that I have prepared earlier. Okay, so here. So next, after we open the RTK plot, it will appear like this. And we need to click on File and open Observation Data. And then we need to choose our observation data. For example, the IR data that I have opened just now in the Leica Spider QC software. So this is the visualization of the IR 041A00 observation data. And we can see that this is actually the visualization of the data. We can also look on the sky plot of the data by choosing sky plot here, and then it will appear like this. This is the sky plot of IR data, and then we need to turn off some of the parameters for the sky plot, and then we can actually see the values of the elevation values of the satellites along the direction of zenith at 90 degrees here. So this is actually the elevation values for the satellite. You can see here we have 15, 30, 45 and so on. So these are actually the elevation values of the satellite for the IR data. Okay, so that's all on how can we visualize the data. So after we have actually evaluate the data, we need to compare all the data in the table. I will show you the example of the table that I have done. So this is the evaluation of GNSS data quality in a table. So we can see here that I put the stations, the general comment, the cycle slip, multipath, data completeness, and also the dilution of position values. So this is how I compare all the data, all the parameters of the data. As I mentioned just now, the cycle slip we have for IR, it is unacceptable and fail because the value of the cycle slip exceed the threshold value, which is 95. Same goes to get to, cry, and see. While for Musa and for Ben, the cycle slip is acceptable because the value of the cycle slip did not exceed the threshold value. So again, we need to bear in mind that the threshold value here that I have done is given by Leica Spider QC software. We can also search on the threshold value from DSMM circulars and other regulations from other countries. Okay, so same goes to multipath and data completeness. Here, the data completeness for IR, it is unacceptable because the value of the data completeness is 97.6%, which exceeds the threshold value, which is 95.0%. So we can see here that the observed data did not go as we expected it to be. Okay. Now we can proceed with the first part of the processing stage, which is the baseline processing. First, we need to know why is the baseline processing is important. So at the end of this process, we need to obtain the global coordinates. And by relating this process to our survey work, for example, the traversing using the total station, how do we get the coordinate? To get the coordinate, we need to have the bearing and distance, right? So at this process, baseline processing process, we can know that a baseline can produce the values of distance and coordinate and azimuth. Basically, it can produce the values of distance and bearing, which is azimuth, and then it can produce the value of coordinate. So we need to also know that what is the difference between azimuth and bearing. So basically, azimuth is the value depends on true north, while bearing is the angle that starts from our north to our point. So in this case, a baseline needs bearing and distance. And to get a good coordinate, we must have a good baseline, because to get a good coordinate, we need to have a good bearing and distance. So therefore, this process is important in order to get a good coordinate. Now I will demonstrate on how did I perform the baseline processing by using the Trimble Business Center software. So we need to wait for a second for the software to completely load. Okay, so we can see here, this is the software of Trimble Business Center, and we can see under the projects, these are the projects that I have done in the software. But for this demonstration of baseline processing, I will be showing the procedure from the first step. So first, we need to choose file. We need to click on the file and then choose new. And then we need to choose blank template, or we can even choose metric template. It doesn't matter. In this case, I choose blank template and I click OK. So it will appear like this, a blank template. Alright, so first of all, we need to import our GNSS data. And in this case, I will import the data. I will click here, import. And then it will appear here, the import window, where I can find my data course L9 data in my folder. So here we have data course L9. I click the data course L9 folder and I choose OK. And then it will appear all the observation and navigation data for the IR and the other stations for the data course L9. So what should I do next is, I will have to select all the data and then I click import. Okay, so when we have imported the data, the receiver raw data check-in window will appear. And in this window, we need to check on the points information, antenna information, and also receiver information. Here we can see the point ID, file name, start time, end time, duration, future code, and also send to RTSPP. For the antenna information, we need to also check on the manufacturer. You can see here, the antenna manufacturer is Leica for Ayurban, Lhasa, and Musa, and SIG. And then the antenna manufacturer for Get to and Cry is Trimble. And then the type and also the serial. Here we need to also know the serial number, which is supposedly provided by the Department of Survey and Mapping Malaysia. But here they did not provide it for us, and that's okay. So for the receiver, we need to also check on the information for the reference station type, manufacturer type, and also serial number. So if everything is okay, we can click on OK. And for projection definition, we just leave it like this and click OK. And our stations will appear like this. Okay, so for the baseline processing, first of all, we need to fix only one of the, here we have 1, 2, 3, 4, 5, 6, 7. We have 7 stations, but for the baseline processing, or we call it trivial baseline processing, we need to fix only one station first. So for example, I choose Amir, I click on the Amir station, and I right click, and I choose properties, and the properties window will appear here. Sorry, the window. We can see the informations for the Amir station. You can see the label visibility, grid coordinate, local coordinate, global coordinate, and also the other informations. So how to fix this station? We need to click on the add coordinate icon, and then here we can see for the point ID Amir, we need to change the coordinate type from grid to global. And then here we can see the values for latitude, longitude, and height for the Amir station. And what do we need to do here is we need to insert the actual coordinate for the station that we can obtain from the MyRTKNet official website. So in this case, our lecturer, Surveyor Dr. Amir, has already prepared for us the coordinates that we need to insert. And here we can see for the Amir station, the latitude is 545, and then this is the second value that we need to insert in our latitude values in the Trimble Business Center software. So let me change it first. 883, 867, 5452, 867, 54. Okay, then for the latitude value, we need to also change for the longitude. We have 78815. 78815. 67, 978815. 978815. Okay, so these are the actual value for latitude and longitude for Amir station. We need to also include the actual value for the height. Here we have for Amir, the value for the height is 67.2625. 67.2625. Alright, so once we have done with inserting the actual values, we need to click on the planar quality of this coordinate and choose control quality. Also for the height, choose control quality, and then we need to click OK. So here we can see the triangle symbol appeared for the station, for the Amir station. That means that the Amir station has been fixed, has been successfully fixed. So now that we have fixed one of the station, we need to perform baseline processing for all the other station that is not fixed, also for the Amir station that has already fixed. So all we need to do here is we need to select all the station here, and then we need to click on under the survey menu. We need to click on the process baseline. So here we need to wait for a minute because it takes a bit of a long time to process all the stations. Alright, now that we have done with the baseline processing, we need to click Save. Okay, after we have saved the baseline processing part, we can just click anywhere at the black background And we can see that all the baseline have turned into blue color, which means that we have successfully did the baseline processing for all the other stations, for all the baselines that is connected to the IR station that was fixed earlier. So now we need to know the coordinates for the IR station after we have performed the baseline processing. So how do we see the coordinate? We click on the report and click the baseline processing report. The baseline processing report would take a bit of time because there's a lot of report to be shown. Okay, so we can see here the baseline processing report will show us the processing summary and then the acceptance summary. Also, the most important part is the global latitude, longitude, and height values that we have observed. So this is the data that we need to take out from this baseline processing report and then put it in an Excel table, and we need to compare the values of our observed data and our existing data, which is the coordinates. So now that we have complete the baseline processing for IR station that we have fixed, we need to, first for IR, we need to save the baseline processing report for our future reference. So click here, export, and then click PDF. And then it will export our baseline processing report in the file format of PDF. Okay, now we can save our baseline processing report for IR like this, for example, and then we just save. Alright, so now that we have already have the baseline processing report for IR, we can close the baseline processing report and we need to do the same step. We need to repeat all steps that I have mentioned before for the other stations. So now we need to undo all actions so that the IR station is back to its initial state. We can just click on undo. Now the triangle symbol showing that IR station is fixed is now gone. We need to do the same thing for the other station and then save also their each and every one of the baseline processing report for each stations. Okay, so after we have finished with all the stations, we need to put the coordinates for the observed coordinates in Excel. So for example, like this that I have done earlier, we need to put it like this. So this one is the for the feed station IR. These are the process station. These are the observed coordinates that we get from the baseline processing report. And this is the known coordinate that we have already been given by our lecturer. So what we need to do, we need to subtract this value with this value to get the difference, because that's what we need to compare. So the same step that we need to do for all the other feed stations. So after we have finished all of this, the baseline processing step has already and successfully done, and we can proceed with the next part of the processing stage, which is the independent baseline. Okay, next is the second part of the processing stage, which is the independent baseline processing. So in order to perform independent baseline processing, we must first create sessions for our baseline. And in this case, for data cars L9 and also loop 9 datas, we have 13 stations involved and 6 sessions. 13 stations involved and 6 sessions were required for us to create. So I have already created 6 sessions, and the sessions are like this. So this is the session that I have created. So the table have 3 columns. First is the session column, session 1, 2, 3, 4, 5, 6. And then the station, the arrangement of these stations in each station is different. For different session, the arrangement of station is different. And then the time interval for all the stations. And here, the start time for my session is 8:15, and the end time for the last session will be at 7:55, and the gap between all the session is 5 minutes, and the interval for every session is around 4 hours. Okay, so now I will demonstrate on how to perform independent baseline processing. So as usual, we will open our Trimble Business Center. Here I have already imported all the session for the data cars L9. Now I will have to import the data for the loop 9 data. So here we'll have to import the loop 9 folder, okay, and then select all the data, import. Okay, so the same goes for independent baseline processing. We also need to check on the antenna point and receiver informations before we click OK. So now I just click OK, and then the data for the loop 9 will appear like this. Okay, so we have 13 stations involved. 7 for the data cars L9 and also 6 from the loop 9 data. So now we need to check on the first session that we have created. Here, first session will start at sit, get to, cry, PTK01, Lisa, so on, and then ends at S0293. So what we need to do here, we need to enter the CTRL on our keyboard, and then we need to click on the baseline according to the arrangement of our first station. So first session of mine start with sit, get to, cry, pity, Lisa. Okay. So I will just here, and then get to cry, and then to PTK1. We can also zoom here, and then to Lisa, and then to Musa, 67 Ayer 17E. So go to 67 Ayer 17E, band, and then after band we have 81 and 93. And 93. Okay, so now that I have clicked all the baseline according to the arrangement of my first session, I will need to check first the arrangement, was it correct? Okay, so when we have already checked the arrangement, now what we need to do is we need to right click and then we choose properties, and then here to recheck if our baseline have included all the 13 stations. Here we can see it will appear 12 baseline. 12 baseline means that we have already included all the 13 stations. See, we can also calculate here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 30 station and 12 baseline. Okay, so now that we have selected all the baseline for our first station, we look at the start time. We need to put the start time for our first station. So our first station starts at 8:15 a.m. until 12:15 p.m. So we put it here. We also need to include the date for the observation because if we did not put the date, the Trimble Business Center software would not allow us to put the time. So where do we get the dates? The dates we can find in the data data itself. So I put here 8:15 a.m. Okay. The end time would be at the same day at 12:15 p.m. Okay, I will enter. And then here the duration will automatically shows that our time interval for the first session is 4 hours. Okay, so now that we have set the time for our first session, we need to right click and then we need to choose process baseline. Okay. Now that the baseline processing have already finished, we click on save, and then just like the previous baseline processing, we just click on the background, and then we can see here that all the baselines for our first session has turned to blue color, showing that it has already gone through the baseline processing. So now this is our first session. We need to export our first session and save to our laptop. So what do we need to do? We need to go to home and then click on export. Okay, and then the export window will appear like this. We need to choose survey, and then we need to choose the Trimble Data Exchange Format TDEF Exporter. So I click here, and then here we need to click on the selected, and then we need to reselect again all the baselines for our session according to the arrangement. So I enter the control button on my keyboard, and then I click again sit, get, and then also for the cry, we need to choose the PP vector, not the baseline, because the PP vector is the baseline that we have already processed. So we choose this one. Also this. Okay, now that we have selected all the 12 baselines, here we need to set our file name. click here, and then we can name it as our first session. Here I put first session and I click save. Now that we have named the file name, we click export. Okay, so we need to repeat the same step, all the steps for the first session. We need to repeat the next step. We need to repeat the same step for the other session. Now that we have completed for the first session, we need to do the same thing for the second session, third session, fourth session, fifth session, and lastly the sixth session. So after we have completed doing the independent baseline for all sessions, we will have in our file all the session. For example, here show we can see here that we have already have all the session after we export the sessions that we have processed. Okay, now that we have exported all the sessions, we have already completed the independent baseline processing. Okay, so the last part of the processing stage is the network adjustment. So I will do the demonstration for the network adjustment. So as usual, we will open our Trimble Business Center. So this is from the previous independent baseline processing part. I will just select all and delete. Okay, what we need to do to perform the network adjustment, we need to import the sessions that we have already saved, that we have already exported from the previous independent baseline processing. So now I will click on the import, and then I will open the directory of the file that I have saved my sessions in. So okay, so here we can see, okay, this is the sessions that we have already exported from the previous part, which is the independent baseline processing. I only exported 5 sessions for my independent baseline processing. So I will just select all 5 sessions like this and then import. Okay, so it will appear like this. This is the sessions that we have already performed in the independent baseline processing. So now, what do we need to do? The same thing that we did at the baseline processing part. We need to fix 1 or 2 stations. For example, I choose SIG. I click on SIG station, and then I choose right click and choose properties, and then I click on the add coordinate. I do the same thing as we did previously at the baseline processing part, and then I choose control quality for the latitude and longitude, also for the height, and then I click OK. Okay, so we can see here SIG station has already been fixed here. So now what do we need to do? We need to select all the stations like this, and then we need to go to the survey, and then we need to click on the adjust network. Okay, here we can see that we have constraints and waiting. So what do we need to do now? We need to click on the adjust to perform the network adjustment. Okay, just click yes here. Now we can see that the red circle appear on each stations, and we can see here that the result show us that the reference factor is 1.52 and the chi-square test is failed, and the degree of freedom is 144. Okay, so how do we know if our test is passed? What do we need to do to get the result to pass? So to pass the result, the reference factor value needs to be 1. It cannot exceed 1 and it cannot be lower than 1. It needs to be 1.00. So now that we have failed, the result is failed, we need to correct the lines that contain errors. So how do we know which baseline have errors? So we need to go to the report and choose network adjustment report. Okay, now the network adjustment report will show us which baseline contains error. Okay, we see here. Okay, here at the adjusted GNSS observations, we can see the Ayah-Kerai baseline have error. So, okay, only Ayah-Kerai lines that have errors. So what do we need to do? We go back to the Trimble Business Center and go to the Ayah-Kerai line. Here, Ayah-Kerai baseline. We right click on the line. We click first and then we right click on the line, and then we need to click on the disable vectors. Okay, click clear adjustment. Okay, so basically we are clearing the adjustment for this line, and then we can see here the adjust network window has been changed, and we need to go to the waiting to see the reference post-process factor. We need to select all first, Okay, and then we need to click adjust again. Yes. And now we need to go to the result is still failed, but we can correct the result by going to the waiting. And then we can see here we have imported post-process vectors. Here we need to multiply the reference factor from the last adjustment with the prior scalar for the next adjustment. Okay, so we click here. Now we see that here it changed to 1.04. So we need to click on adjust again. Yes. And now the result is pass because the reference factor is 1. The value of the reference factor is 1.00. So as I mentioned before, the reference factor must be 1.00. It cannot be lower than that, and it cannot exceed than that value. So now that our result is passed, we have already successfully performed the network adjustment. Okay, now that we have successfully performed all 4 of the pre-processing and processing stage in the GNSS data processing, we have already finished, and I guess that's all from me. Thank you for watching and have a nice day. Assalamualaikum warahmatullahi wabarakatuh.